Hi, 7th graders. Today we're going to quickly review scale factor, and then I have 3 examples, and then 3 that you'll do on your own, and then the back side is independent practice. Example number 1, Ms. Dargan drew 2 triangles on the board. The triangles are proportional, so that we know that means that they are equivalent. So this length and this length are equivalent to these two. They're proportional. If the scale factor is 4, what are the missing lengths of the triangle? So we have 3, I can get this, 3 is looking normal, and 6. And we have a scale factor of 4. Well, I know this is a whole number, so this means that my second triangle is going to be 4 times the size of my first triangle. If this length is 3 times 4, this length would be 12. If this length is 3 times 4, would also be 12. If this length is 6 times 4, this would be 24. This is a scale factor of 4. It's getting bigger times 4. I want you to do the next one independently and then come back to the video and press pause right now, do the next problem, and then come back and watch example 2. All right, if you are watching this, it's because you've already done the first one on your own. We have example 2. This example says, Mr. Mark drew 2 triangles on the board. The triangles are proportional. What is the scale factor from rectangle 1 to rectangle 2? So we have rectangle 1 and rectangle 2. We see that rectangle 1 is bigger than rectangle 2. It has a side of 4 and 16. And then this one has a side of 1 and 4. And this time we want to know, what is the scale factor? I keep calling them triangles. This is rectangle 1, this is rectangle 2. I go from 16 to 4 and 4 to 1. Well, scale factor is similar to constant of proportionality in the way that we can probably identify that this is divided by 4. 16 divided by 4 is 4. 4 divided by 4 is 1. But I don't have a scale factor of divided by 4. My scale factor has to just be a number. It's not just going to be 4, because that would imply that it's getting bigger, that it's times 4. So if it's divided by 4, we know that that's the same thing as multiplying by 1/4. So my scale factor is simply 1/4. Anytime you go from a larger image to a smaller image, the scale factor will be a fraction. I want you to press pause, try the next example on your own, and then come back for example 3 in just a second. All right, if you are watching again, you are in example 3. Example 3 is one where we could use a calculator. So I have my calculator out, ready to go. It says a right triangle has legs measuring 4.5 meters and 1.5 meters. The lengths of the legs of a second triangle are proportional to the lengths of the first triangle. Which could be the lengths of the second triangle? Select each that apply. So we've seen this problem before, and a lot of us had questions on it, so I'm going to go over it now. What I would do, given this information, I know I have a triangle, and it said it was a right triangle, so I'm just going to draw a picture of the triangle. I know one leg, and this is not to scale. One is 1.5, and the other one is 4.5. I'm imagining another triangle then. It could be bigger, it could be smaller, but I know it's proportional. I know that these have to be proportional. If I'm looking for proportionality always goes with unit rate, okay? We know that the constant of proportionality is the same as the unit rate, or the constant rate of increase. With unit rates, I can make ratios. So I know it's 4.5 meters to 1.5 meters. And I want to check out some of my examples and see if they work. Number 1 says 6 meters and 2 meters. This is A. So I want to see if this is proportional. Well, I don't know off the top of my head 4.5 times what is 6. So I'm going to divide, and I got to use a calculator. So 6 divided by 4.5. This got me about times 1.3333. This goes on forever. Now, I know this will be proportional if this one is also times 1.33333333. So I'm going to try that in my calculator. 1.5 times 1.33333333, and I got 2. You will get in your calculator, it might look like this, 1.9999999. It just hasn't been rounded up. This would round up to 2. If it's extremely close so it looks like it's 2, it would round up. So A does work. 6 to 2 is absolutely correct. I'm going to keep my same original proportion and try the other ones out. The next one is 8 meters to 5 meters. Again, I don't know 4.5 times what is 8. So I'm going to do division. 8 divided by 4.5. I got 1.777777777. So I'm going to do the same thing. This should also be times 1.7777777. You'll see that it's given to you in your calculator like this. I can just simply multiply this number by 1.5 and I should get 5. I multiply it, I get 2.66666. That does not work, so B is not proportional. The next one is 7 and 3.5 meters. Okay, again, I don't know what to do here, so I'm going to divide. 7 divided by 4.5, and I get 1.555. So I'm going to say that if this is times 1.555, this should be as well. Let me see. Ooh, I got 2.333. That's not 3.5, so C does not work. The next one is 10 and 2.5. 4.5 times what is 10? I don't know, so I'm going to divide. 10 divided by 4.5, and I get 2.22222. So this should also be multiplied by 2.22222. I get 3.33333. That does not work. So that one is not correct. The last one, I have 11.25 over 3.75. Again, I don't know what I multiply, so I'm going to divide. 11.25 divided by 4.5 is 2.5. Let's do this one, 3. So this should also be, this is times 2.5, so this should be times 2.5. 2.5 times 1.5 gives me 3.75. Perfect. A. And the last one was E, I believe. A and E are my correct answers. I know that's a lot. If you're confused, please watch it one more time. You have the rest of your packet. Good luck.